this video, I will be explaining how to set up a network using VLSM. First, I will show you how to do it in binary, and then I will show you how to check your work using a chart. The example. A small company needs to set up its network across several locations. The New York branch office needs 15 computers. The San Jose office needs 66 computers. The Trinidad office will need 18 computers. You will need 2 wide area network links between the routers. Using the IP address 195.20.5.0/24, divide the network using VLSM. Include the name and subnet IP addresses information for each branch of the network. Label the wide area network links with the same information. We will be working from largest to smallest. To begin with, we know that subnet 0 will have a subnet address of 195.20.5.0. Subnet 0 needs 66 hosts. Each bit can hold 2 hosts, though you have to account for the subnet address and broadcast address since you can't give these addresses to a host. So we're going to come up here and see which bit will hold 66 hosts. 2, 4, 8, 16, and 32 aren't large enough to hold 66 hosts. 64 is almost large enough, but it's not enough to hold 66 hosts, so we're going to have to go into this bit, which will put your line of demarcation right here. The binary value for this bit is 128, so we can add 128 to this subnet address to get the subnet address for subnet 1. This will give you the broadcast address for subnet 0, which will be 1 less than the subnet address for subnet 1. The last usable host will be 1 less than the broadcast address. The first usable host will be 1 more than the subnet address. To find the subnet mask, you have to determine how many bits you borrowed from the network portion of the IP address. Each byte is made up of 8 bits. There are 3 bytes right here, which give you a total of 24 bits. Since you borrowed this bit, your subnet mask will be 25. Subnet 1 needs 18 host addresses, which will fall under this bit, which puts your line of demarcation right here. You can figure out that your subnet mask will be 27 by counting 25, 26, 27. The binary value for this bit is 32, so we're going to add 32 to 128 for a total of 160, which gives you the broadcast address for subnet 1, which is 1 less than the subnet address for subnet 2, which gives you your last usable host and your first usable host. Subnet 2 needs to hold 15 hosts. You might think that this bit will hold all 15, but you have to remember to account for the subnet address and the broadcast address. This bit will only hold 14 usable hosts, so we're going to need to go into this bit, which you'll see that you're still in the subnet mask range of /27. Since the binary value for this bit is 32, add 32 to 160 for a total of 192. This will then give you the broadcast address, the last usable host, and the first usable host. Subnet 3 needs to hold 2 hosts. Remember to account for the subnet address and broadcast address, so we're going to go into this bit, which puts your line of demarcation right here, which gives you a subnet mask of 30, 25, 26, 27, 28, 29, 30. The binary value for this bit is 4, so add 4 to 192 for a total of 196. Your broadcast address will be 1 less. Your last usable host will be 1 less than the broadcast address. And your first usable host will be 1 greater. Subnet 4 also needs 2 hosts, so you'll stay in the subnet mask of /30. Add 4 to 196 for a total of 200 minus 1 for the broadcast address. Checking your work with the chart is very simple. Remember that subnet 0 needs 66 hosts. So you'll come up here and find which column 66 hosts will fall under, which will be this column. You'll see that it determines that the IP address range will be from .1 to .126. If you check your chart, you will see that the subnet 0's IP address range is from 1 to .126. Since we've used this column, we'll come on down. Subnet 1 needed 18 hosts. 18 hosts will fall under this column. The column predicts that the IP address range will be from .129 to .158. Let's check our chart. As you can see, subnet 1's IP address range falls under 129 to 158. Let's come on down. Subnet 2 needed 15 hosts, which will remain under the same column, which predicts an IP address range from 161 to .190. So let's check our chart. There it is, 161 to 190. The last two subnets needed 2 hosts each, which if you look right here, says that the IP address for the second to the last one will be 193 to 194, and the last one will be 197 to 198. As you can see from our chart, our work is correct.